Hello friends, in the last lecture we are discussing about different types of the secondary measuring instruments, in which let us see the electromechanical indicating instrument. For satisfactory operation of electromechanical indicating instrument, three forces are necessary. Which are these three forces? First one is deflecting force, second one is controlling force, and third one is the damping force. Let us see one by one. The deflecting force. When there is a no input signal to the instrument, the pointer will be at its zero position. To deflect the pointer from its zero position, a force is necessary which is known as the deflecting force. A system which produces the deflecting force is known as the deflecting system. Generally, a deflecting system converts an electrical signal to a mechanical force. There is nothing but the pointer scale. Next one is the, let us see in detail. To have a deflection, we must have the magnitude effect. So let us see the first one, that is magnitude effect. When a current passes through the coil, it produces an imaginary bar magnet. When a soft iron piece is brought near this coil, it is magnetized. It's a simple Oersted phenomenon that when current is carried by a conductor produces its own magnetic field. And when a magnet or any conductor brought, that soft iron piece is a conductor, is brought near to this coil or a conductor who is carrying a current, that piece, soft iron piece or the material, will get magnetized. There is a magnetizing effect. Depending upon the current direction, the poles are produced in an S pole, obviously, in such a way that there will be a force of attraction between the coil and the soft iron piece. This principle is used in moving iron attraction type instrument. This is the same principle is used in the motor also. See, when current carrying conductor is placed in between the magnetic field, it experiences a mechanical force. The same principle is used here. If two soft iron pieces are placed near a current carrying coil, there will be a force of repulsion between the two soft iron pieces. This principle is utilized in the moving iron repulsion type instrument, a repulsion. Next one is the force between a permanent magnet and a current carrying coil. When a current carrying coil is placed under the influence of a magnetic field produced by a permanent magnet, and force is produced between them. This principle is utilized in the moving coil type instrument. Next one is the force between two current carrying coil. When two current carrying coils are placed closer to each other, there will be a force of repulsion between them. If one coil is movable and other is fixed, the movable coil will move away from the fixed one. This principle is utilized in electrodynamometer type instrument. So there are three different effects. One is used in the repulsion type instrument, second one is used in the moving coil type instrument, and third one is used in the electrodynamometer type instrument. Next one, this is all about the deflecting system, deflecting force. Let us see the next one, the controlling force. To make the measurement indicated by the pointer, a force is necessary which will be acting in the opposite direction to the deflecting force. This force is known as the controlling force. A system which produces this force is known as the controlled system. When the external signal to be measured by the instrument is removed, the pointer must return back to the zero position. This is possible due to the controlling force, and the pointer will be indicating a steady value when the deflecting torque is equal to the controlling torque, and that controlling torque is given by the spring. So there will be a steady state position when deflecting torque is equal to a controlling torque. So this controlling torque, controlling force is provided by spring control. So let us see this spring control. Two springs are attached on either end of the spindle. A spindle is placed in jeweled bearings so that the frictional force between the pivot and spindle will be the minimum. Spindle means nothing but the coil which is wound with respect to each other around itself, around one axis. Two springs are provided in opposite direction to compensate the temperature error. The spring is made up of the phosphorus bronze. When a current is supplied, the pointer deflects due to the rotation of the spindle, which while spindle is rotate, the spring attached with the spindle will oppose the movement of the pointer. The torque produced by the spring is directly proportional to the pointer deflection, that is a theta. So controlling torque, that is the torque produced by the spring, is directly proportional to the theta, where theta is nothing but the deflection by the pointer. The deflecting torque produced, that is a TD, is proportional to the current. So when TC, that is controlling torque, is equal to deflecting torque, the pointer will come to a steady position. Therefore, as TC is equal to TD and TC is equal to theta and TD is equal to current I, so we can write therefore theta is equal to I. That is, theta is directly proportional to the current. It means that the deflection of the pointer is directly proportional to the current carried by the coil. Since theta and I are directly proportional to the scale of such instrument which uses spring controlled is uniform. So uniform scale. So this is the diagram indicating the control mechanism with the help of, or the control torque or control force produced by the spring. Let us see the next one, damping force. The deflection torque and controlling torque produced by the system are electromechanical. Due to the inertia produced by the system, the pointer oscillates about its final steady position, that oscillation like a pendulum position before coming to the rest. The time required to take the measurement is more. To damp out these oscillations quickly, damping force is necessary. This force is produced by different system, like to remove the oscillations uh, uh, from one point to the another point. A, a pointer gets oscillates in between these 2 points, so it doesn't come to the steady state position and never indicates a accurate reading. So to avoid these oscillations, there must be a damping. So to have a steady state position over scale, so that there will be an accurate measurement with no any error. So that is provided with the help of the damping system, damping force. So there are three different ways to provide the damping force. Method 1, air friction damping. Second, fluid friction damping. And third one is the eddy current damping. We'll discuss these dampings in detail in the next class. Thank you.